Okay, so the lab today is going to involve 3 different solutions, and all of these are electrolytic cells. You have to have the batteries. So over here on page 2, here are the solutions that you're going to be working with. So nitrate, sodium iodide, and sodium chloride. They're all mixed up. They're all sitting up there on the front island. They're all going to have like pipetted. So the battery source, so we're just going to use like a simple 9-volt battery. Okay, so you got that. Then all you have to do, and you're going to have leads. So just hook one up to each terminal, like so. Not the most high-tech thing in the world, but it works. Okay, so you got this set up. And then you're going to take a piece of graphite. And what I would recommend is that you take one and, because this is pretty cheap and you don't want to cross-contaminate these. So I'd like break it in 2 and then put one in each side, like so. And then like so. Okay. Now, to make this simple and minimize the amount of solution that you're going to use, and this also allows you to run multiple attempts. Just get a small, you should have like small weight just like this. If you don't, I got more. And you're just going to take a little bit of that sodium iodide and just kind of put some of that in the corner like this. Okay, literally, that's all that you need. Okay, just a little bit. Now, because of the fact that you can run a whole bunch of multiple solutions with this, multiple trials, you're going to have 3 different indicators that you can use. You can use bromothol blue, so that works with the study. You're going to have our old friend phenolphthalein, and you're also going to have a universal indicator. Or you could just run it with no indicator at all. Okay, so that's the beauty of just using small little samples like this. So you can have it like this, kind of have it tilted a little bit so that it's all kind of pulled in one corner. And then all you have to do is take these, don't let them touch, and just put that into the corner of that solution, like that. And right away, you should begin to see something happen, okay? All of these are home run reactions. So for example, this is sodium iodide. So the first thing that you've got to do, and if you notice on this one, you kind of probably can't see it in the back, but there's kind of like a yellowish liquid that formed, and then I also had a bunch of bubbles. Now, I didn't add in any indicator at all. Sometimes it's handy to run it without any indicator because of the fact that if you are producing like a precipitate or a color change just based upon the elements, if you have an indicator in there, that might mask that color. So that's why I said it might be handy to run these without any indicator at all. You can run one because you're using such a small amount of it. You can run multiple trials. Hey, let's try it with bromothol blue. Let's try it with, phenolphthalein. Okay, so you can run multiple trials. But here's the most important step, and this is why over here on page 2, where, for example, it has the silver nitrate one. Well, let's just do the sodium iodide because that's the one that I just did. So in this beaker, or that flask technically, in that flask, what do you have in that flask? You have 3 things in that flask. You have water,
Sodium ions and iodine.
you have sodium ions, and you have iodine. That's it. Okay, that's it. You don't have hydrogen, you don't have oxygen, you don't have hydroxides, you don't have H pluses, you don't have elemental sodium, you don't have elemental iodine. So on any reaction that you have, these are the only 3 possible reactants that you have. You do not have sodium, you don't have iodine, you don't have hydrogen gas, you don't have oxygen gas. This is it. This is it. Now, one of the first things you have to figure out is which one is the anode and which one is the cathode. So this is why, if you do that silver nitrate first, the silver nitrate is kind of a home run. So I would run the silver nitrate first, which is why this is first. Because if you look at that reaction, that will clearly identify which one is the cathode and which one is the anode. If you run that silver nitrate one, because let me give you a hint. Ag plus is going to do what? It's going to gain an electron and turn into elemental silver. So that's why I would run that one first, because you know this is going to happen. And once you see that silver forming, and don't go around like, hey, Mr. Burkamp, can we take that silver and sell it? Okay?
What?
I think we all know who would come up with that scheme. So it's going to be such a small amount, it's really not worth it. Okay? But that will allow you to identify where the reduction is taking place. So where that reduction takes place, is that your cathode or is that your anode?
Cathode.
That's your cathode. So if I would run that first one and go, okay, hey, because on all of you, you have two different colors of wires. That way you can identify, oh, on this situation, hey, is the black or the green one my cathode or my anode? That way you'll know which one it is. So here's what I want you to do. On the observation, you're going to write down, hey, what do I see happening at the cathode? What do I see happening at the anode? It might be, are you producing a solid? Are you producing bubbles? If you added phenolphthalein, is there a color change to magenta? If you added bromothol blue, which changes in an acidic solution, hey, did that happen? If you use universal indicator, beauty of universal indicator is that you can see both the acid and base, because that's going to change in both situations. So this is what I want here. Just don't write a reaction took place or it looked different. Okay, I will flip out. So write down observations, just not it looked different or there were bubbles. Okay. Now, when you get down here to the questions down below on page 2, here's the heart and soul of the lab. So, review your observations for the electrolysis of the silver nitrate solution. What product was formed at the anode in the electrolysis of silver nitrate solutions? Explain, citing specific evidence from your observations. So, what was made? Was it oxygen? Was it hydrogen? Was it hydroxide? Was it hydronium ion? Was it silver? Was it iodine? Was it whatever? Okay? Just don't say, oh, I think we produce silver. Why? Bless you. What happened to lead you to that conclusion? If you think you produce oxygen gas, look at your reduction table. If you think you produce oxygen gas, what else is the byproduct that is associated with the production of oxygen gas? Is it hydronium ion? Is it hydroxide ion? If you think you made hydrogen gas, great, fantastic. What else is there? Okay? So just don't say, oh, I think I made oxygen because they're bubbles. Okay? You cannot look and tell the difference between oxygen bubbles and hydrogen bubbles. Okay? And no, you cannot collect them and make them go boom. Okay? Because you're not going to make that much of it. Okay? So, you're going to do that on question number 1. You're going to explain what happened at the anode, and then you're going to say, hey, what happened at the cathode? And then you're going to you'll do that same process for the sodium iodide, the same one for the sodium fluoride. Okay? I want specific examples and justification for what happened. Okay? Bubbles is not it. That's an important part of it. But you have to have something with it. That's why I said you can run multiple tests with multiple indicators. When you get down to number 4, for each of the 3 cells, write the overall balanced reaction. If you want to do the half reactions, you can. That's up to you. But at the end of the day, you really need to be able to say, hey, this is what's the overall reaction. When you get to question number 8, okay? So question number 8 on the back, you got 2.5 amps. So in silver nitrate, you run it for 2 minutes. What's the mass of silver formed? Obviously, that should not be a very big answer, okay? Because you're only running 2.5 amps and you're only running it for 2 minutes. When you get to 9, okay, only do delta EK for the electrolysis of silver nitrate. I do not want you to run them for all 3 reactions, just for the electrolysis of silver nitrate. Now, when you get to number 10, here's what's different on number 10. All I'm going to tell you is that I'm going to drop a piece of copper into a solution of silver nitrate. Write the balanced equation, all this good stuff. When you get to number 10, assume the copper ends up at Cu2+, okay, because that's the most stable form of it. So it does not go to 1+, it goes to Cu2+. So on number 10, assume that it ends up at Cu2+. Okay. Other than that, I'm done. Now I'm done. Be free. You can wash all the solutions down the sink. They're very, 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 very dilute. So here we go, kids.